Okay, am I audible? Okay, so I have.
Audible.
Okay, okay, okay. For this, you need MATLAB software for performing different tasks. Okay, so first you can see right here. This is a simple MATLAB window. You can go to mathworks.com and you can download the MATLAB version. I have 2022 version, so you can also download from here, and you can start this window online also. Uh, for 1 month, it is free if your university is taking the licenses, then it is free for the teachers also. So right here you can see in the yesterday session you also seen MATLAB programming. So right here on the left hand side you will see the workspace where all the folders are available. Right here, this is a window where the text editor is there. You can write a code, and this is a command window. Whenever you write or execute something, the command will display the result right here. And this is a workspace where whenever you perform some operations, all the variables will be stored right here, and all the models which you create, that will be stored right here. So this is a workspace. So this is a simple introduction of this MATLAB. Right here on the left hand side, whenever you want to create a new file, you need to click on this plus sign, and this new file will be created right here. Okay, so I already started with this execution. So you can see right here the size of this image data set. Right here, label resized images are not available. Does not have any files on this. This is a empty. Okay. So first of all, what we have to do, we have to give the path of the folder where your data set is available. So right here, you can see this is the command, and this particular file location is there where I have stored my data set. So what you have to do, you have to copy the path, and you can uh, click on this, and you will see this is the folder. Semantic segmentation. This is the dataset folder. In dataset, images are there. These are some color illumination images, image resized. These are some resized images, label resized. This image folder is empty. So that's why it is creating the error. So labels are there. So first of all, you have to understand right here what we are performing. We are performing supervised learning or unsupervised learning. In this particular example, we have images, original images, as well as labels of those images. So you can see uh, all the images are available, and their ground truth images where the forgery is present, those parts are also available right here with me. So what we are going to do, we are going to train this particular model, and you can see how much images are there. The size of those images are 47,820 824 images are there. And when you see the complete image dataset property, you can see right here what is the size of this dataset. So right here, it is calculating the size. So you can check right here size of this disk. So size is 21.9 GB, means 22 GB of this data is there for the training only. So your laptop, if you are using your laptop and you are using convolution neural network, simple convolution neural network, so your machine is not going to perform this particular task on this simple computer. And first of all, you can check the property of your system. When you go to this PC, you will find the properties right here. For this PC, I'm using i7 processor, and RAM size is 32 GB, and I have NVIDIA GPU also in this system. So it will work for few images, not for this particular data set which I'm showing to you right now. So first task is right here, but you have to take few images to perform this particular task. Okay, so what I'm going to do, I'm just I will take just uh, few of the images. You can check what we have done right here in these images. When you check the size of these images, 480 by 360. So this size is different. In our model we are using 114. Why we have taken 114 in our model? You can check the size is larger. If your size is larger, then more iteration is to be performed, more epoch is to be run, and more computation time is there. Okay, so to reduce the computation time, either you have to remove some images, or you have to reduce the size of your image. So right here what we have done, we have few images of let's suppose that 15,000 images, yeah, or 10,000 images. So after 10,000, how you want to increase the size of those images? So right here you can see all the images are rotated. You can see R8. R8 means uh, rotated by 8 degree. Okay, and when you see right here, this is a ground truth. This is a ground truth means it's an original image. And after this, what we have done, we have changed the color of this image. After this, what we have done, after changing to, this is a R2. R2 means rotation by 2 degree. Then what we have performed right here, we have performed a pre-processing task. So how you can perform this pre-processing task, let me show you first. Okay, so this is a reshape file name I have given. And what we have done right here, first you can see close all, it will close all the windows. So when you run this particular command, you can see evaluate section in command window. So when you run this, you can see all the workspace is cleaned. Okay, all the windows, when it is showing some windows of figures, those will be closed. Clear all is going to clear our command window. Clear variable is going to clear our workspace. Clear global, all the models which are saved right here, those will be closed. Close all the windows of images are going to close. So let's see. This is the first variable which we have taken as train one, and image data store is a command where you can select the complete data set. So right here, what we have done, we have given the path of the image. So let's suppose that I am taking the data set one, and I am taking the images of dataset 1. So let's see, this is dataset, and this is dataset 1. So what we have done right here, you can check how many images are there. Ground truth images we have taken 3986 images are there. So these are ground truth images, and the size you can see right here, 480 480 by 360 is the size. Okay, so this is the first folder which we have taken images. Then second folder we have taken is labels resized. Label resized, where is this folder? You can see right here, label resized. This is the empty one. So what you have to do, you have to either create it. This one is the folder label resized. So in this label resized, what how this these images are the labels of the original image. You can see right here, this is GT1, and inside this dataset 1 images, this is GT1. So somewhere right here there is posed portion of the particular object. Let's take another example where we can visualize clearly. So let's suppose you can see right here this particular image. Okay, so see this image. This tank is not original. This is one frame, and this is a second frame. Two videos are combined together right here. So we have to detect this particular tank, which is a forged one. So let's take this original image, and what is the number? GT335. GT335. So labels, you can see in the labels 335. So this is 335. So right here you can see this background, background means it is authentic portion, whereas this white background means it is a forced portion. So we have to detect this forced portion, and this is a video. uh, this background video, and this is a foreground video. So this is a interframe forgery. We have to detect this interframe forgery. So how we have to detect? First, we have to convert the whole video into frames. Then we have to find out the ground truth images. Then we have to train our model by showing these forged portions to the model. So it will learn which portion is forged and which portion is authentic. And whenever you on a real time you give the result, give unknown image, it will detect automatically which portion is authentic and which portion is forged one. So let me show you right here. So what we have to do, uh, you will take the second image as second folder as a labels. So what we are doing right here, we are going to create uh, the empty files to be filled by these. Okay, so what we are going to do, first we have taken, first folder we have taken in train 1, second folder we have taken in train 2, then we are taking train 1 dot files. So let me execute first, first of all these two, evaluate selection. So when you execute this, you will find the workspace right here, and right here you can see the files, and here you can see the location. So it will take the first image GT1, and train 2 files. You can see right here, it will also take the first image as GT1. Okay, and what it is going to do, it will take the label image and it will take this images GT1 image. Okay, so what it will do, uh, you can see right here. Okay, so evaluate this section, and right here, this size 1 is, what is the size? 3986 by 1. So this is the size. All the images are going to be placed in one particular variable. So it will calculate the size of all the images. So how much images are there? You can see 3986 images are there. So this for loop is going to be run up to 3986 times. So what is this for loop is going to do? It will first read the train one first image, x1 means first image. Then what it is going to be do right here, it will store that image into y1 variable. Then the second by2 variable will store the image of train 2 first image. And then what we are doing, we are resizing that image. So you have seen in our presentation that we are using the size of the images as 114 to 114. So first you change the size of this by3 as well as by4 variable. So let me first change this value 114. After that, what we are doing right here, we are using this function I am subtract. So we are subtracting the label from the images, and we are finding out the portion of that image which is forced one in a Wi-Fi. And after that, what we are going to do right here, we are converting that IM to black and white. So it's up to you how much intensity you have to provide for this by 6. So that will be converted into black and white. If you don't want to convert into black and white, then you have to just give the variable value right here. So that will be stored into this Wi-Fi. Okay. Then we are taking this ms to y6, and then we are using this function ms function, and we are taking only one channel. It's up to you. If you want to convert that image into black and white, only one channel you have to provide, or if you want to give a three channel image, then you can take it as a three. Then you can apply these things. Let me first show you this thing only. So I'm not going to use it. I will comment these things, and right here I'm using this by 5. After subtracting this image, I'm getting by 5. So what you have to do, uh, you have to take one folder, and you have to write that particular value into this particular folder with the name. We have given a name as a GT percentage D. Percentage D means but 1, 2, 3, 4, and we are taking this X1. So X1, you can see right here. So X1 is this value, first value, first image value is this, and it will be stored right here. I am right using this. I am right. So it's up to you where you want to store. So let's suppose that I'm going to store this into resized value label. I have to store all these value into labels. Label resized. That folder is empty. I have taken that folder as an empty one because we have to convert this thing to show the demonstration to you. So I am using this label labels resized. So first you check the name of the folder is same or not. Labels resized. It is available right here. Okay, so GT1, 2, 3, 4 all are available. If you want, it will be overwritten. Uh, so what you have to do, either you will take this one or label images. Okay, I will take this image resized. Run this. So it is busy right now, and you can check in the folder your images. Earlier you have seen all the images are in black and white. Now the size of the images are also changed, 114 cross 114, and 335, GT335. This is GT3, okay, 325 or 335. You can see. So till this point, it is clear to everyone what we are doing in pre-processing. Quickly, if you if you are listening, please unmute yourself and say something. Am I audible?
Audible, sir.
Yes, sir,
Audible.
audible, sir.
Okay, okay, okay. So till this step, you are clear how we are performing different operation to images. Okay, so this is a pre-processing step. I'm not going into detail. Uh, Let me explain this particular code to you, and you will perform this task by your own. Okay, so right here what we are doing, we have performed the pre-processing step. Then after performing pre-processing step, we have to provide the folder name where your data set is present. So you can check this data set one we have given. So give the name dataset one, and inside this dataset one, the folder name is images. So all the images are going to be loaded into this image directory, and with the help of this image directory, you can find extract the file location with the help of this IMDS. And IMDS comma 101 means it will take the image from location, from that particular location, 101 location, and it will show you the image in figure. So let me execute this thing. What we are doing right here, you can see the workspace is on the right hand side. All the variables are present right here. I'm again executing clear all, so this will clear. Let's suppose that we have given a equal to 10. So this window is there, and something is written right here. And on the right hand side, workspace is also shown, and some variables are also shown over there. So when you execute, everything is going to erase. Now we have to take one example to load that particular folder and show one image. The location is 101. So I am executing it, and you can see at location 101 it is showing me this image. If you want to change this location, so it will give you different image. I'm changing this image, and you can see right here, if it depends upon how much images you have, till that point it will take, otherwise it will create error. So it's okay. So this is the image. Okay, after this step, what we are doing, we are defining the classes. So what are classes? Either we have to identify this particular image is post one or authentic one. So you have seen the data set. You have seen the data set. Images are there, and inside these images, all the authentic portions as well as post portions are there, but the labels are correct. So these labels are showing the first portion of that image. So we have to identify the two categories. So that's why we have taken the classes as forced and authentic. Then we are using right here the color pixel labels, and those color pixel labels, black is authentic, and white one is forced. So that portion which is highlighted with white is to be considered as forced one. The portion which is black, that is considered as optional one. So right here we have given the path of the folder where the labels are available. So right here you can see uh, this label folder is there. So when you click it, label folders. So this black portion is authentic one. This white portion is called forged one. Okay. So after this, what we are doing, we are giving the classes and labels to this pixel variable, and again, we are taking one image at a particular location from the particular location, and with the color map, we are using this overlay operation, and we are displaying that image. So you have to, if you want to show this to the user, how you are going to identify which one is forced one and which one is authentic one. You have to use the same image, otherwise it will not show you the correct result. I have used this 333, so it's up to you. Whatever image you want to take, you can take right here the same image, and overlay image location is also you have to define same as above. Okay, so right here I am going to execute this, and after this you will see the overlay of that image. So select it and evaluate this section. Okay, so this particular function which is right here, cam bid, so it is going to be executed, and that is written below to this particular convolution neural network. So that's why I am executing just our portion. So it is not showing. I have to execute the whole code, then it will show. Okay, so right here you can see, uh, right here, this one. So this white portion right here is a forged one, and the background portion, which is in brown color, that is authentic one. Okay, so after this, what we have to do, we have to find out the frequency of force pixel as well as color pixel. So the frequency level is given by calculating all the values. It is executing the whole program for this data set, and this data set contains 22 GB of data. So it will take some time, but it will again show some error because the folder is empty over there. We have to perform this task. So this machine is not going to execute the complete code, but it will execute the complete code on a GPU. Okay. So right here, what we have done after this, we will calculate the frequency, and that frequency will be shown in a bar graph. So we have created a figure, and we have created a bar graph right here. And the frequency classes, there are two classes. One is forced one, second one is authentic, and that particular graph is going to be shown over there. Okay. After this, what we are going to do, we are taking the data set image resized and label resize. Why we are performing this task? Before performing convolution operation, all the images should be in a same size. Let's suppose you are taking 114 by 114. So all the images should be in the same size, and color channel should be same. So then it will perform the convolution operation. If the image is one of the image is not in a proper size, then it will not perform the convolution operation. It will generate the error. So this is the main problem. So you have to perform pre-processing step and convert all the images into equal size to perform convolution operation. Then what we are doing right here, we are preparing a training and testing data set. So this type of frequency graph is shown right here. Uh, and in this particular training portion, what we are going to train, we are going to train the pixel with the test data and train data, then IMDS test data and ambient train data. So we have created these pixel level training as well as image level training. So by there are two type of images right here. One is a ground truth RGB image, and the second image is black and white, that is label image. So these two folders are for the labels, that is black and white, and these two folders are for the color image, that is RGB. So GT image, which you have seen in the image and image resize images. Right here, after this, what we are going to do, we are using training and testing values from these files, and then again we are going to convert. So right here, what we have taken the size 360 by 480. It's up to you. If you want to change the size to 114 by 114, you can change right here. And then number of classes, we are taking two classes only. It's up to you. If you want to use this particular algorithm for your operation or your algorithm or your particular application, then you can change the number of classes right here. We are using AlexNet pre-trained network, which has image pre-trained model, and those models are taken right here, and we have used this net model. Uh, all the values which are AlexNet is a pre-trained model. So that model is going to be loaded into this variable net variable. And then we are taking the layers of this LXNet, and we are modifying all these layers right here. So why we are performing this task? Because when you train your model from the scratch, it will take so much time. So what we are doing, we are not performing training from the scratch. What we are doing, we are taking the pre-trained model of this LXNet, and we are modifying its layers, and then we are training our images on particular application. So our application is to identify which portion of image is first or which portion of an image is not first. So two class classification is there. So that's why we have used LXNet, and with the help of LXNet, we are modifying their layers, and we are training our model for two class classification of this forced and authentic type of data. Okay, so right here, what we are doing for the layer one, we are taking the input image size 480 by 380. You have seen above. We have taken this size. Then we are taking the color, this dimension, three channel dimension is there, red, green, and blue. And then we are taking this layer one as a data augmentation, and we are performing this normalization operation for this layer number one. So what do you mean by normalization? Normalization means if your data is not properly distributed, you have to you have to divide that particular value with a maximum value, so that your data will be uh, normalized to particular range in a let's suppose that if some value is higher, so one value is 0 and 1 and 2, and second value is 255. So the maximum value is 255. You have to divide with that 255 value, so that the all values should be in the same range, 0 to 1. Okay, then what we are doing right here, we are defining the weights for the layers, and here you can see 6 cross 6, then 256, then last value is 4096. So we are reshaping the layers. We are taking the by size 1 comma 1, and then convolution 2D layers we are taking with a filter size of 6, then 4096 uh, values, then number of channel 256, and fully connected FC6 layer. Then again, what we are doing right here, we are modifying this layer number 20, and here we are taking weight as 1 and 409696 parameter right here. And then we are using this convolution 2D layers, and performing all the operations to this convolution layer with the parameters like stride, padding, number of channel, weight, learn factor. I already explained all these things in my presentation, where you have to take the stride, why you have to take the padding, what is the number of channel, weight, learning factor, and all these things. So after this, the layers are to be arranged right in this manner. First is a convolution 2D layer, then upscore, then you have to use the 2D layers, then softmax layer, then pixel classification layers. Then you have to take this L graph, and the layers are combined for pixels and the images, and based on those pixels and images, you have to uh, give the final result. So right here you have to plot where is the force portion, and where is not force portion. And for this training, we have taken the momentum zero point 0.9, initial run rate 1 e raised to minus 3, L2 regression 0.005, maximum epoch up to 10, mini batch size 10, shuffle every epoch, and execution environment you can see multi GPU. So if your system support GPU, then you have to use it. Otherwise, you have to leave it blank. Or you can replace this with the CPU. Then plot training process. Then verbose frequency you have 10. So maximum first you can say 10 values it will show in a one window. So then data augmentation you have seen right here. So you have to take the data augmentation, then you have to start the training. So training process is used with the help of this train network. So train network is going to be performed on data source, graph, and the options. Options you have taken right here. So these are the options. All these values are going to be taken right here. Okay, in the option section. And graph is a pixel value, white and black, two type of pixels are there. So graph values will just taken right here. Then data source contain the images, and all the images, and then white and black pixels. Then training options you have taken, and then you have to train the model. And the model is going to give the result inside this net variable, and to store the information into this variable info. After this, you have to test the image and perform some semantic segmentation, and you have to show the result uh, by displaying which portion is forced and which portion is not forced. So we are using this label overlay, and we have to pair those two images. On the left hand side you have to take the original image, and on the right hand side you have to show the forced image. Then you have to use this C map and define these classes, which portion is forced and which portion is not forced. I have shown this result inside my presentation to you. So it is not possible for me to execute this whole code right here because it will not work. We need some GPU to execute this. So it will show in a pair, and it will show the result as a actual and expected. And here some frequency measures, and our this AIU table will be generated right here. And then after this we are using this pixel result for semantic segmentation, and perform these matrix operations over there. And right here you can see we have defined this cam bit pixel IDs. So we are taking only two label, 255 for authentic, that is white, and 0 for false, that is black. So right here, these are also the functions which are used to create these two type of pixel values, and overlay those values. So you can modify these also for sky, for other background. Uh, so this code is for demonstration. If you able to understand this code, then you can say something, or if you want more explanation, then I can explain more. So unmute yourself if you want to say something. Otherwise, I am concluding my session right now. This is our last session. I again request you to please complete this particular quiz, as well as your feedback form submission. So right here we have 54 responses. We have total 60 participants. So still six persons are absent. Please check your name right here. If your name is present, then it's okay. If your name is not present, so you will not get the certificate. This is one criteria for filling this particular completing this quiz. And second one is your feedback form. So you need to complete the feedback form also. So you can see right here, this is the feedback form. Still, we have 15 participants who have not filled this feedback form, please check your name. If your name is not in this feedback form, you will not get certificate. Okay, so it's up to you. If you want, you have to fill it. If you don't want, it's up to you. Okay, please check your name. If your name is not present, then 45. Still 15 left. If you have any question, you can ask. Otherwise, I'm leaving this session. I will close the form at 8 p.m. Uh, till 8 p.m., this form is open. After 8 p.m., I will close this form. If you want to say something, you can say. Otherwise, you can leave this session. We are closing.